This is MOSFET, and MOSFET is one of the most common electronics components ever. It is used in billions of electronics devices today, including this particular one you are using to watch this video. In this video, I am going to tell you everything you need to know about what this type of transistor called MOSFET is, the types, the characteristics, and so more. So stay to the end of this video to learn more about this component. So along the way, if you think I am giving you value in this video, please slash the like button and subscribe to this channel. The full meaning of MOSFET is metal oxide semiconductor field effect transistor. This transistor is a semiconductor device that is widely used for switching purposes and for the amplification of electronic signals in electronic devices. A MOSFET is either a core or integrated circuit where it is designed and fabricated in a single chip because the device is available in very small sizes. The introduction of the MOSFET device has brought about a change in the domain of electronic switching. So let us go with a detailed explanation of this concept. So, what is a MOSFET? A MOSFET is a four-terminal device having source, S, gate, G, drain, D, and body, B terminals. In general, the MOSFET body is connected to the source terminal, forming a three-terminal device such as a field effect transistor. A MOSFET is generally considered a transistor and is used in both analog and digital circuits. The functionality of a MOSFET depends on the electrical variations that occur in the channel width, as well as the flow of carriers, either holes or electrons. The charge carriers enter the channel through the source terminal and exit via the drain. But a MOSFET can function in two ways: depletion mode and enhancement mode. Each class is available as N-channel and P-channel. Hence, overall, they tally up to 4 types of MOSFETs. So let's talk about the 2 ways they function. 1. Depletion mode. When there is no voltage across the gate terminal, the channel shows maximum conductance. When the voltage across the gate terminal is positive or negative, the channel conductivity decreases. 2. Enhancement mode. When there is no voltage across the gate terminal, the device does not work. When there is a maximum voltage across the gate terminal, the device shows enhanced conductivity. The N-channel MOSFETs are abbreviated as NMOS and are symbolically represented as shown. Similarly, the P-channel MOSFETs are abbreviated as PMOS and are symbolically represented. One of the most important parts we must talk about is the operating regions of MOSFET. A MOSFET has 3 operating regions. Let's talk about those regions. 1. Cutoff region. The cutoff region has no conduction, so the MOSFET is off. In this condition, the MOSFET behaves like an open switch. 2. Ohmic region. The ohmic region is a region where the current IDS, which is the drain to source current, increases with an increase in the value of the VDS, the drain to source voltage. When MOSFETs are made to operate in this region, they are used as amplifiers. 3. Saturation region. In the saturation region, the MOSFETs have their IDS constant in spite of an increase in VDS, which occurs once VDS exceeds the value of pinch-off voltage VP. Under this condition, the device will act like a closed switch through which a saturated value of IDS flows. As a result, this operating region is chosen whenever MOSFETs are required to perform switching operations. So, now let's talk about MOSFET as a switch. MOSFETs are commonly used as switches. This circuit shows the configuration of a MOSFET when it is used as a switch. In the circuit arrangement, an enhancement mode N-channel MOSFET is used to switch a simple lamp on and off. The input voltage VGEs is adjusted to an appropriate positive voltage to switch on the device, and the voltage level is set to a negative value or 0 to turn it off. There are a lot of MOSFET applications, but these 4 are the most common ones I know. 1. MOSFET amplifiers are widely used in radio frequency applications. 2. MOSFET behaves as a passive circuit element. 3. Power MOSFETs can be used to regulate DC motors. 4. MOSFETs are used in the design of the chopper circuit. So now let's talk about the advantages and disadvantages of MOSFET. The first advantage of MOSFET is MOSFETs operate more efficiently at lower voltages. And the second advantage of MOSFET is that the absence of gate current results in high input impedance, producing high switching speeds. The disadvantages of MOSFET are also that MOSFETs are vulnerable to damage by electrostatic charges due to the thin oxide layer, and also overload voltages make MOSFETs unstable. So by now I hope you have learned something new about MOSFET, and I hope I provided you with value in this video. Please slash on the like button, comment your thoughts about it, and please do me a favor by slashing on the subscribe button for more educational videos about electronics. Have a wonderful day. Peace and love.